Good morning. My name is Justin Johnson. Today I'll be presenting the scenario for Universal Flowers Racing, which is a global race organizer with the goal of funding charities through different racing events. Their current landscape consists of a series of disparate regional databases that they are looking to decommission and replace with a unified Salesforce solution that is rolled out in phases across America in 6 months and in Europe in a year. Their outcomes that they're trying to achieve with this org is a race operations platform with long-term reporting abilities. They'd like to adapt to LDVs and also that will be a part of the solution, as well as address some of the governance issues with regards to the fragmentation, which I'll address in the risks. Moving on now to risks, we have a control risk here that I've identified where there's no development and deployment guardrails. This can be mitigated using a center of excellence that would provision a CI/CD pipeline and change advisory board for deployments for ensuring that whatever is going in production is approved. There's another risk around compliance, specifically with regards to the EU and United States compliance. I recommend that we embed the Romanian team for EU compliance in the steering committee and also in the center of excellence so that there's compliance there with regards to the regulatory standards, and that we enable Shield for the privacy center. Then we also have a steering committee that applies a strategic vision and apply a federated COE model with a centralized COE that is able to apply global best practices, and then federated COEs for regional flexibility. Finally, we have the timeline risk where we have a constraint for 6 months for a pilot, which we could really this risk culminates in distributed teams that cannot scale with the velocity that is expected in the 6-month timeline. I recommend that we apply a RACI matrix, that there's accountability applied across different teams or applied to areas based on the team composition, and then we have delegated decision authority so there isn't any bottlenecks. Some of the assumptions I made is that Salesforce system of record for race operations, tracker database and system record for the racer tracking, and then I'm also applying a pub sub integration model there. Okta as an identity layer where the internal authentication happens through AD, external through the current LDAP. The DashPay is a payment gateway. The race registry as system record for race history, and then we have a static single page application via CDN for guest tracking where the ESP owns the RFIDs that are private, and then the tracker IDs will be public that map then to those RFIDs. Okay. Moving on now to the actors we have internally, we have the regional managers and the race coordinators and the territory route leaders. They've all received Sales Cloud license for the access to opportunities. Regional managers all the way down, roll down a role hierarchy with record visibility that cascades up. Customer support receives Service Cloud license, and they exist outside the role hierarchy, but they receive Service Cloud license for access to cases. External users include the racers that receive Customer Community license for access to records, the charity personnel that receive Customer Community Plus license for reporting and sharing, and advanced trackers that receive Customer Community Plus for advanced sharing as well. Moving on now to some landscape, we have a single org here to unify data processing collaboration, multi-language, which is enabled through custom labels and Visualforce email templates and translation workbench for the translation of metadata via a translator point of contact. The multi-currency is also enabled given the global reach here. The single org has Chargent installed for the payments that is integrated with DashPay, which is access the gateway via a PCI integration, compliant integration. Digital engagement is for the outreach as well as live chat that is required as part of the solution. Salesforce Voice, which integrates with Amazon Connect for CTI as a CTI solution. SDocs acts as the PDF generation tool that will attach records to PDFs to records and send those out. And Shield will be enabled for the EU compliance. Internal users will authenticate via Okta, backed by an internal Active Directory ID store. That Active Directory ID store here, that they will also authenticate into the internal app the same way. The internal app itself authorizes using authcode plus Pixie Flow. The Racer app, external users will authenticate using an using the auth provider that is provisioned for Facebook and Twitter. That provider, the auth provider will validate the ID tokens returned by these social media providers, and then that will then provision them. If the external users choose to authenticate using username and password, they will authenticate instead via Okta, which is backed by the external LDAP, and that will be using SAML. The Racer app itself is authorized using that same authcode Pixie Flow and auth. Okay. We take an API-led approach to integrations, connecting systems using reusable APIs, managed by an ESB and secured by a JOT-based trust model. The ESB itself integrates with the public single-page application for those public guest users, the vendor trackers, the race registry, and tracker database using different protocols I'll describe later. And then the ETL acts as the data migration tool for the decommissioned databases. Okay, moving on now to the requirements. Starting with the race planning and race registration, we'll start with the leader, where the leader will create a race record. The race record is represented by an opportunity. When they create the race record, opportunity record here, they will also have the ability to go into the mobile app and then leverage an LWC that is enabled for geolocation to store opportunity products that represent the race waypoints. Those race waypoints are stored via that mobile app and are saved based on their location, and the LWC saves the geolocation there too. Okay, the race waypoints are not visible by default, but they are visible to the territory route leader and their respective managers via the role hierarchy. They are only visible at the point when on the race day. This is enabled based on cloning of the opportunity product records that are private, controlled by parent, to the race to the waypoint custom object here that is under the race record. When the territory route leaders are satisfied with the series of waypoints, they will submit them to a race coordinator using the opportunity stage as submitted. That will trigger an approval flow that will go to the coordinator. The coordinator will then create a race record that is a draft record that is owned by the leader. And then that sets once the race is allowed and it's approved, it will set then the status to open where everyone can see the race. The race is set to status open by the leader, and then there will be a criteria-based sharing rule that will share once the race status is set to open, it will share the race with all users via criteria-based sharing rule, and then there'll be a validation rule as well to restrict edit on the open races. There will be, for the leaders, they will be able to do reporting and analysis using standard reporting on the race summary, which is an aggregated object that includes the results, the race results for the different racers. And I'll talk about how that's generated later. They should be able to also do standard reporting and dashboards from their mobile device as well, using that Salesforce mobile app. The racers will be able to access the portal using social sign-on. The social sign-on is enabled via these auth providers here. That will then provision them within the org using a registration handler. Otherwise, if they self-register, that would be done through Okta, and Okta will then provision them within the external LDAP as well, and also provision them separately within Salesforce. Okay. The race record, once it's created, so once the racer has been provisioned within the org and they are set up as a person account, that will then create that'll then trigger an integration with the registry to using a request for reply pattern via REST API, which will be facilitated by the ESB to return the registry ID that is stored on the person account itself. The legacy systems that we're migrating from, these racer databases, currently do not have the registry IDs. What we'll do is, as a part of the migration, populate those legacy IDs with the populate those racer records with the legacy IDs so that they are populated within the org with those. If the racer is provisioned, or if they're registering themselves and the registration handler identifies that registered user as a duplicate, then they will be brought to a login flow, screen flow, which will ask them to confirm that if any of the records that are presented are the same. And if they are the same, they will choose to reset the password, which will then initiate a password reset for that user via Salesforce. Once the racer is authenticated into the racer portal, they'll be able to access the races via search on the race object that will be exposed, and that will allow for them to then register later on. They will also be able to search within Mobile Publisher, that Mobile Publisher app that they have access to as well. If they choose to, they can update their personal information using self-service on the person account. Once they have access, they can also then register for races using the registration object. That registration object is the creation of registration records is done via a screen flow on the race object on the race layout itself. They have access to waypoints via the race relationship, and the waypoints are only created on the start date of the race. They will be able to view their info in previous races via the integration with the registry system. So what I'm assuming in the solution is that the ESB will be able to integrate with the registry system via APIs and expose OData connectors that will then surface external objects for race and race history. Those are then surfaced with restriction rules so that there's not visibility issues or oversharing of records. And then the racer personnel data, if they do update their racer data within the system on their person account right here, they will integrate with the registry system using Fire and Forget via CDC, and the ESB will orchestrate then the communication or orchestrate the subscription as well as communication with the registry system via custom channels. There will be an LWC for the racer race summary so that racers can view a report of races run, and the registration status will be visible via the registration records themselves. And if the race itself has a maximum capacity set by the race coordinator, they will set that on the race record, and we are restricting the limit of registrations per race based on a record triggered flow that will count and increment the count of registrations per race. And if the capacity is beyond or below the registration, then we'll close the race and it will no longer allow for registrations to be created. There will, of course, be, like I mentioned, this registration screen flow that will allow for them to register for the race and state their competition level. That will be based on the level that they specify for the first screen. And then once they've specified their competition level, there will be a payment screen that will allow for them to pay. And this will be using the charge and order payment method, where the charge order will be created once they're passed on the second screen, and then that will facilitate the payment via the ESB via the charge and integration. The charge and integration will what users will be able to do is they'll save the credit card information, which is tokenized within Salesforce itself, but the credit card information is stored on the payment gateway side, so that we're not violating any PCI requirements or regulation. If the charge and order transaction fails, then there will be a record flow that will notify then the racer that the payment was unsuccessful, and it will update then as well registration as inactive or as unpaid. DashPay will store, of course, the payment information, and transaction will be processed in DashPay. And we are using Chargent for the purposes of limiting the dependency on DashPay for development, since it does also serve as a backend gateway for other systems. So we're leveraging Chargent for that purpose to limit the amount of modifications that or development. It limits the strict coupling that Salesforce does with this gateway. Once the registration has been paid, it will update the registration as paid via record flow. Then there will be an additional record flow that will update the registration with a unique tracker ID that is generated via Apex. That unique tracker ID is also emailed to the racer, and then the Salesforce will integrate with the ESB to store a mapping of tracker IDs to RFIDs once they are identified. Once the tracker ID is created and once the RFID is known, then the ESB will store within its mapping for quick read access the mapping so that guest users, and I'll talk about that in a moment. The registration will be controlled by parent, which looks up to a charity. That's the charity itself is defined by the racer, so the racer will be able to select the charity. And then the system will check to see if the registry system to see if the racer has raced more than 5 times in the past 2 years. This will be triggered via record flow that will query the external object record count to see if it is above 5. If it is above 5, then the racer will receive an email to opt into the registration premier flag, which is a flag on the registration record itself, and that will then determine if they will match the total pledge amount. Racers will be able to ask questions via chatter, and then they'll be able to also search the site for materials. The materials themselves are stored within the system using knowledge articles, and those are translated via translation workbench. The racers will be able to raise requests using the case object that's related to the registration. And if they, and there will be different case types based on the type of case, based on the type of customer support requests that they are, or tickets. If the racer chooses to cancel the registration, there will be a cancel registration button on the registration layout that will be called canceled, and that will trigger, once they cancel, that will trigger then an integration with the adventure trackers using a request reply via REST API, which the ESB will orchestrate and determine within the ESB whether or not to return a flag for the half or full for the refund based on the shipment status from return from the adventure tracker system. And moving on to the race day. On the race day, there's a requirement for the general public to watch the racer's progress on a map, and this will be done using the unique identity, that ID that was generated before, and that will then bring up the racer's limited information. So one of the things identified as a stressor in this scenario is that there will be peak loads that occurred during the events where a lot of guest users will be accessing the portal at once. So we need to optimize for reads with CQRS and event projection to ensure that we are limiting the number of reads that are happening or we're facilitating quick reads as well as limiting the number of queries that are happening directly to Salesforce databases. So in order to facilitate this, whenever the tracker system publishes an event that identifies a racer has passed a waypoint, the tracker will publish an event using pub/sub with the ESB that will map the RFID to the progress, and that progress is based on the geolocation. Then the ESB will store within it the mapping of that progress, so that when the guest users refresh the SPA page, the single page application page that is external to Salesforce, that it will be able to then quickly read based on the tracker ID and using request reply the latest progress of the racer, which is based on the last telemetry event. So at the ESB layer, we will be storing a per tracker ID / RFID, the latest progress, so that we're not having the general public doing continuous queries against the tracker database or Salesforce. Okay. So if the guest user, when they view the profile, wants to donate amounts, they can enter a pledge amount that will create a pledge record within Salesforce that will also redirect them to DashPay for the payment. And then that will include in the URL, of course, the pledge ID. If the pledge is successful, so if the payment is successful from via the DashPay, that will then return a successful message to Salesforce that will then update the status of the pledge to success. If it's failed, then the pledge will be updated as failed, and it will email the guest user based on their email that was also inputted as a part of the pledge record creation. Okay. There is a large data volume requirement here that requires 5 years worth of historic race information. So we won't be storing race information and pledge information directly within the system. As soon as it's non-operational, we will tier it so that non-operational records are aggregated within a racer race summary object. And then we will do the same for the historic data for 5 years. So the past 5 years of data as well. As part of the migration, we will also create race summary records for that as well. When the racer is registered, so when that registration record is marked as paid, there will be register flow that will create the shipment request. The shipment request is for that racing bib and RFID tracker that will integrate with the adventure trackers database that will allow for that will output to the ESB the racer bib number, the RFID number, and shipping tracking number for each racer that's returned then to the registration record itself via the ESB. And then we will rely upon request reply for the shipment status tracking. So whenever a racer wants to see their latest shipment tracking, they can request they can refresh the page, and that will then make a real-time request reply via ESB request so that they get the latest shipping status on the registration. That will be done using that shipping tracking number that's stored on the registration itself as well. 10 days prior to the race, the racers are broken up into start groups. This will be done using a scheduled flow that will update the registration with the start start group per race with group based on the group batch sizes that were specified on the race. If it isn't specified in the race record, that will default to 50 racers per group, and also it will respect the per registration flagging for Premier as well. If once the registration race group has been assigned, then there will be an email that's sent out to the racer with the group as well. The tracker database, I'm assuming, will be the system of record for the latest tracker location. That's what we're relying on as well for the pub sub and the CPQR integration with the ESB that is optimizing read operations. So we're not actually making direct requests. We're relying upon the tracker database for pub sub that will then be subscribed to by the ESB and then persisted within the ESB temporarily. Okay. There will be scheduled apex so that once the after will send the charity organization payments, this will be done via the ESB that will aggregate the pledges that are associated with the race itself, and then the ESB will orchestrate then the debiting of the payments to the charities via DashPay. The regional managers will be able to edit the charity accounts based on their region. There's only 3 regions, and so I'm relying upon criteria-based sharing rules for edit access so that the regional managers have access per region. And then once the pledges have been debited to the charities, we are going to have SDocs generate a PDF, which is installed, that will generate a PDF with the totals per pledge, and that will then be emailed to the charity personnel. That will also be accessible from the system for downloading at any time based on the attachment of that PDF to the charity record as well. And then we will, one day after the race, furthermore, we will, using that scheduled apex, we'll aggregate the data, the pledge data, onto the pledge data as well as the racer results onto the racer race summary object, and that will then be stored for its non-operational and reporting purposes. The pledge data itself will then be deleted so that it's not so that it isn't taking up space on the platform and limiting the performance of the platform. Okay. The charity organizations will be onboarded using a web URL or through email. This will be done using web to lead or email to lead. That will then create lead records. Once the lead record is created for the charity, the territory race coordinator will review the application, which is the lead record. And once they validate it, that will then be submitted to the regional manager using a submission, using approval flow. The regional manager will then review and approve. That will then convert the lead to a business account for that charity. The charity themselves will log in via Okta. They will be also provisioned within the external LDAP, similar to the racers that choose to authenticate using username and password. Once they are registered, they have the choice of also provisioning additional users for their charity, and they will do that based on the designation of a single charity personnel that will be able to provision users for that charity, and that will then propagate to the external LDAP as well as to Salesforce. The charity personnel will be able to ask questions on the forum using the chatter feature, and then they will also have the ability to view knowledge articles that are translated via Translation Workbench. Charity personnel will be able to log in and view the donation pledge reports using the association with that race summary that includes the aggregation of the donation amounts per racer. And then the charities will be able to run reporting on the race summaries for the last 5 years using that object as well, and that will use standard reporting since they are receiving Customer Community Plus license. They won't be able to view any racer details based on the fact that they have field level security restriction. The charity personnel will be able to view information about the organization, but they will only be able to update certain information on the business account, such as contact information. This will be done based on their FLS as well. And then they can also create cases related to their business account to request other changes such as bank routing number and mailing address that is stored in DashPay, and that is then processed by internal admins. The territory race coordinators and regional managers will be able to run reports on historical and current data based on the standard reporting. We are creating race summaries the day after the race completed. So I'm assuming that current data here isn't, active races. It's all data. It's historic data, as in it's current data includes data that is current data includes the race data, and then historic data encompasses all of that. There's a governance risk here that describes a disorganized and maybe some competing priorities with regards to where the funding should, where the focus should be with regards to the direction of universal racing, and what identified here is a need for a steering committee that will apply a vision of a solution, and then center of excellence guardrails for the IT solution. That will then lead to definition of ready stories that will align with the PMO expectations and then CMO requirements, so that there's complete alignment with regards to what's being developed, so that, and also, of course, those will follow sprint life cycle and sprint reviews, so that there's complete awareness across the board about what's being developed. Finally, at customer support, we have the customer support users called out here that will be able to take on the cases that are raised by the racers and the charities. They will be able to do that through multiple channels. They can do it over the phone, which is facilitated via Salesforce Voice, and then that is routed to specific agents via omnichannel. The cases themselves are look up to the registration, and they also look up to the registration, the charity. The case internal customer support will be able to view all requests created by charity personnel and racers, regardless of region or territory, based on the criteria-based sharing rule that will then share read-only access to the support role. The Salesforce will integrate with the Adventure Tracker system and return the shipping status based on that request reply pattern that I described earlier, which will surface the shipping status on the registration record itself. When a case is created, there will be a record trigger flow to assign ownership of the case to the territory queue. That includes a territory queue that includes the territory route leader and territory race coordinator. That will allow for them to handle complaints that are created for races that they are assigned to. If the racer bib or radio frequency tracker has not been received, then and the racer has made is raising a case for that. That is a specific case type that will be routed to the territory race coordinator immediately. There will also be a escalation rule to notify the manager if they haven't resolved it within 1 business day, and the territory race coordinator is immediately notified via their ownership on the as via their ownership on the case. And then finally, we have the registered racers and charity personnel that will be able to chat with all the agents via digital engagement. Moving on now to the migration. So starting out here, one of the main sources that I identified was the racer databases, which include the racers, the charities, pledges, and the pledge history. I'll start with the racers and charities. Those are both constitute master data in my model that will be operational, continue to be operational. So we'll be migrating all of those over. And the pledges and the race history will be aggregated within the ETL pipeline here. So the data steward, first of all, will profile the data that exists within the racer databases. Of course, was identified before was the duplication. They will then align with the key stakeholders on the target schema mapping, the data quality standards, and then we'll provision the ETL pipeline that will then migrate the data over for the racers and the charities. That will then cleanse, deduplicate, assign external IDs from the racer databases, and then the objects themselves are ordered from parent to child. The pledges and the race history are also migrated in. They will then be aggregated into that object that I described earlier with the racer race summary. That aggregation will then be the last thing to be migrated over, since there is references within those to the master data records for racers and charities. Once that is brought into the pipeline, then we'll run rehearsal migrations for the migration itself, culminating in a controlled cutover window for specifically the American data that will then create for that specific regional data, the person accounts, the business accounts, and the racer race summaries and the race records. Those are then created for that initial phase for the pilot, and that will be the initial proof of concept for the eventual rollout for EU. As a part of the development itself, we will incorporate EU early on in the process so that they can identify areas where there's awareness of reusability of some of the components that will be a part of the solution itself. Once the migration has occurred, there will be smoke tests that are done by the data steward to ensure that there's alignment. If it meets expectations, then there's a sign off on the go live. And that concludes my presentation. For any questions, thank you.